Okay, so we are live. I was getting really confused because YouTube was telling me that we're not live. So I guess we can start then. So let me just quickly set this to public. Done. And now I can share this with some folks, set my notifications off, and we can start living with various bits and pieces. Let me just figure out how to do that because I've forgotten how to use this because I haven't streamed in ages on this system. So I want to go somewhere down here. Where's my notification drawer? Yep, brilliant, you're on Do Not Disturb already. Cool. So got it. Okay, so there we go. I have two concurrent viewers, so I'll wait for viewers. But essentially on this stream, what I really wanted to do, there we go. What I wanted to do was to develop this. So this here is my PCB 1.4, and let me see if I can grab my 1.3 board from over here. Should be different. This here is 1.3. Albeit with a few wires next to it, because I've been testing some prototype circuitry there. But as you can see, quite a big difference between the boards, between the two designs. There's quite a few different things going on here. For starters, I guess I could actually say some of the main differences here. Ignore the fact that this has got a MOSFET missing and it's here. This is so that I could prototype test this circuit on this board here. So first of all this MOSFET array stuff here is gone, and in place is this very expensive IC by Infineon. It's a TLA, I remember exactly which one, it's TLE9 something. It's a 6 low side driver IC, which I've got on the board. So this is driving 5 of the solenoids, and the 6th one being the torque converter is being driven by 2 MOSFETs, and this will become a little bit more apparent later on in my development series on this board as to why there's 2 MOSFETs controlling 1 solenoid. Essentially, you have a Zener diode to protect against reverse flow current, but you actually want to turn that off at a specific point in the torque converter solenoid cycle, so it dumps all of its current out in one go. Before, for instance, with this board, we have a problem with the circuit on this whereby it doesn't do that, and as a result, the torque converter kind of stays. The torque converter solenoid will kind of get stuck open if you send a PWM signal to it, because it can't dump it, so it then stays open, and then your torque converter is stuck at 100% open all the time, and it creates some inconsistent locking. So to fix that, we have that. Also, we have some more safety things here now. So, for instance, we have this guy. This is a high-side power switch by Infineon with smart monitoring, so it can monitor the current being consumed, reported back via this external ADC. So we have now one ADC to control a lot of analog pins, and that's also to free up the pins used by ADC2 on here, because I want to eventually get Wi-Fi and Bluetooth working on the chip here, but the one block for that was on this board. ADC2 on the Espressive chip was responsible for a lot of the solenoid current measurements, and because of that there's a hiccup with the ESP32 itself, whereby if you're using ADC2 you cannot use Bluetooth and Wi-Fi concurrently. So now that we have ADC2 on here freed, we can now use Bluetooth finally, so I'm quite happy about that. And then also we've moved to linear voltage regulators. Yeah, they consume a little bit more power, but equally they have a shut off. The sensor supply is also being monitored up here by the ADC, so we can monitor in real time the consumption of the sensors and detect if there's a short circuit, and then shut this thing down if that does happen. So like the OEM EGS52 module and 53 as well, they have that same functionality whereby if they detect a high flow of too much current being drawn by this guy, by the sensors in the gearbox, then it cuts the supply off and puts the PCU in emergency mode, so that we don't experience an overcurrent situation. Other than that, the board is essentially the same, except it's also a quad layer board, so this is a lot more expensive for me to produce because the old 1.3 boards were 2 layers, which was cheaper and easier to produce, but these are now 4-layer boards because I actually wanted to do proper ground planing and noise filtering. Not noise filtering, but reduce the amount of noise from the power rails onto some of the signal lines. So there's that. Lastly, one thing that I found on the 1.3 boards is that this tiny little guy here, this is the CAN EMF CAN filter, which goes up to the CAN lines. I had like I think 2 or 3 boards whereby this guy here would pop off because it's so small. So I beefed it up, and this is a bigger one now. So there's no chance this is gonna fall off anymore. So let's get started. I'm gonna first of all plug the TCU in. Now it's gonna beep uncontrollably because it's currently running firmware and it doesn't know what board it identifies as. Essentially, there's a eFuse block on the ESP chip itself that in the configuration app I set one time on there when I make the boards or whatever. So, or when you do it, there's a guide on GitHub on how to do it as well, how to set the eFuse on here correctly to the right board. And then once you've done that, the board always knows on boot up which variant it is and sets the pin configuration and everything accordingly. So let's let me just quickly do this. I'll drag this VS Code window out, open recent, config app. Now apologies if my laptop does decide it's going to scream. Let's check out PCB 14. Git merge dev. Oh, okay. Cool. So I'm going to first of all push this branch for PCB version 14 or 1.4. And then I guess, I don't know where to really start on this really. So I think first of all what I'm going to do is I'm going to add support in the config app to set board 1.4. And then I guess the TC won't know what to do anymore because it will go to main.cpp here and realize somewhere up here the board config, here we go. So yeah, if it's, okay, then I guess here I need to set PCB board matrix version 1.4. Class V14 is GPL matrix with IO expander. Okay, that makes sense because it has the IO expander up here. So V14, then I can go here and I'm gonna literally just copy this. Maybe I'll make a new class. Yeah, let's just copy this guy here for now. Yeah, we'll just copy him down here. So for now, it will base off the same V14. Yeah, okay, we'll fix that. PC board matrix 1.4, and the date today, since we're making this matrix today, is 30th of 24. Cool. Now I'm going to have to open up on here KiCad to have a look at my schematics for this. I will be eventually releasing the schematics online, obviously once I've done all the testing on the board, because I want to make sure everything works before I release the schematics. So right now don't copy anything, because this could all blow up when we start testing. I don't know yet. So okay, so I'm going to put this to my laptop screen. Elsewhere I don't need that, I just need the reference for which pins are connected to where. I'm going to make sure CAN is on GPIO 5+, that's correct. CAN minus is on GPIO 18, that's correct. Piezo speaker is IO 0. Okay, so the basics are there. And then everything else is not connected. Oh, I2C clock is GPIO 4 on this board. And I2C data is GPIO 2. So they did change a little bit. Sensor data, function function data, this. Okay, I'm gonna actually let's just undefine all of this here. I don't know what's gonna happen when I run this. Stephen Vick says, I was super interested in this project until I saw the price. Well, if you want, you can go ahead and make your own board. The schematics are all online. I have the parts list and everything, so it's up to you. You're more than happy to go and make the board yourself. But I mean, if you pay for it, you are paying for like the amount of time, because I spent like 2-3 years on this software now. And also all the utilities config app and stuff, and I do have services which I'm running for like the documentation and stuff, so I do have to pay for all that. So that's what the money's for. But other than that, yeah, you can go ahead and make it yourself if you want. Right, where was I? So in here, I believe I settled on calibration, device modes, flash identification. I need to do calibrations. Yeah, my laptop's taking off again, please ignore that. Ah, here you go. 1.3, 1.4. 0. Let's make sure no equals 1 equals 2 equals 3 equals 4. 1.4 HDS equals 0xF4. Oh no. I guess I could do anything really. Error expecting comment, thank you. Oh wait, this is the wrong thing I'm editing. For some reason, Rust Analyzer is just absolutely consuming my CPU right now. Where do I need to go for this? It's in, I can't find an ident. It's somewhere. I haven't looked in this code base in ages. Oh, there you go, configuration mod. So I need to go all the way up here, and I believe somewhere here I have about E-fuse. There you go. Board type, there we go. V1.14, V1.14 is 4, and V1.14 HDS is equal to 0xF4. Then for now, we're just going to copy all the images across, because I want this just to compile right now. I don't care about it working properly. 1.4. HDS 1.4 HDS enclosure 13th of 05/24. So in theory that should be it. I should be able to now apply the fuse configuration, or not. Why don't you like that? Oh, here. Refresh, TTY USB 0, launch, reconfiguration, set board. There's no 1. Oh, I think I know why. I haven't actually listed that yet. So it'll be somewhere here. 1.4. 1.3 config. There we go. Now that should work. Let me go ahead and plug that USB back in. configure read 1.4. Right. Yes. General reject. Oh, that's interesting. So the ECU actually said no. Which means I must also have somewhere in here. So, refuse. Search somewhere in here. So be in right. There you go. That's why. Board version equals 0. Or board version is greater than 4. Okay, so now I have to upload this, and then it will let me flash it. So that's interesting. Possible serial noise or corruption. I got this before once on this board, and I'm not too sure why. If I can't actually flash it, then we have a problem. Invalid packet header 0x46. Possible serial noise or corruption. I mean, it's working. It's not able to send a reset signal to the board. So I don't know what I should do now. Because you can hear it, like it's beeping, so I've clearly been able to upload firmware to this before, but it now doesn't want me to upload to it again. And invalid reset signal means essentially like, well, actually, what happens if I press the reset button whilst I'm flashing? Could I revive it? Oh, there we go. Yeah, I just have to press the reset button. Cool. It can work. And now it doesn't want to boot at all? Hello? Oh, there you go. Okay, so I think I know what's happened. The reset button has probably got stuck. So that's not a problem. I can work around that later. View read. So it's now set to 1.4, right? Yes. Okay, defuse applied. And now it should say the same error in the serial port. Yeah, but it found it. So it says here config board version 1.4, but then it's having a go at me because it's saying it's not a valid defuse. So we now go here to main.cpp, and I should be able to hopefully set that. Case 4, V14 GPIO matrix. Let's upload now. EEPROM init fail would be because there is no mince we got here, then that's it initializes the speaker, I think. IO0 is on speaker. Okay, so now let's go ahead and run this again. Oh, wait a sec, I need to close the serial monitor. Okay. I heard that pin make a noise. Basically, when signal is sent through IO0, I can hear it pinging a little bit sometimes. So that's interesting. I've noticed that. Right, read configuration. So we'll set that. EGS cam layer, let's say 52. Right. Cool. Sensor init fail. Yeah, that's fine. I'm expecting that. You're now seeing the config app, it's not happy at all. Failed to output reg, IO expander, LDC channel config, GPI num. Failed to output reg. Could I have mixed them up in, or did I edit the wrong, shoot, did I edit the wrong thing here? No, that is 1.4. SDA is GPIO num. Oh, SDA is GPIO num 2, and SCL is GPIO num 4. So I got them mixed around. And then that should mean that the speaker pin should be IO num 0. Robert asks, you're wondering if my TCU could be used on a manual converter card to simulate an automatic transmission. Technically yes. I don't see why it can't. But there is a lot of black magic involving this since stupid thing upload. Since you have to also send gearing information to the car, so you can't just like simulate it blankly. You would need to know roughly what gear the car is using, ratio information, so I suppose you could do it intelligently. But I don't know if that would cause any further issues down the line. Okay, sensors init fail, so I'm gonna unplug, actually, you know what, I'm gonna actually comment the speaker pin back out. This way it doesn't keep beeping all throughout the stream. Yep, you know, so we have this now, and I don't think I need the config app anymore actually. So that's useful, I guess. We can just now use code. So I think first of all what we can do, because using the TLE chip seems like an absolute bullet, because I can show the datasheet here, it's huge. Instead what I guess we could do is we could actually work on using the ADC. So there's now an external ADC on the board here which deals with a bunch of readings, rather than using internal ones on the ESP chip. So I suppose we could just try getting that to work today. But anyway, this is the datasheet for the TLE chip. So many registers I can write and read to. Like, it's lovely, but basically the TLE chip is used to do constant current. So for the SPC and MPC solenoids, it's going to be, I think it's something like 0.02 milliamp precision on that. So I'm pretty happy with that. And then on here we also need, what's the ADC I used? I used a ADS, this one. ADS 115 DIG, I think it's just package differences. Data sheet. Okay, so I've got a data sheet for this guy now. And I believe I set the address at 48, so we can create a class for external ADC and just have fun. Right. Trying to find the protocol information down here. Okay, so address pointer register, I don't need that. A conversion register, 16-bit conversion results, first 16. Okay, so let me try something now. We go because I don't want to accidentally do 2 tasks at the same time trying to request over SDA. That seems like a terrible idea. So I think something on here. Yeah, we have this IO expander, and then if I copy this here, rename xadc.cpp, and then we'll copy this here, rename xadc. Okay, let's see. So I'm just gonna uncomment all of this guy for now. Class external ADC, ADC. Okay, so if include external ADC, and I don't need this information anymore. So I want to quickly see, is the IO expander here? What's the IO expander task doing? I believe my friend Christian wrote this thread here. Right, looking quick at chat here. Yeah, so the reason why the compressor clutch will not engage when you are driving without the TCU is because the engine ECU basically has something saying like, if there's any fault code, I'm not going to engage the supercharger because I don't know if that's a safe operation. And not having the transmission, or not having the right data being sent from the transmission, or not having the right parity information on the transmission will all cause a trouble code to be flagged, which would disengage or not allow the supercharger to actually engage. So that's why. So it's a little bit more complicated than it's just that you don't have a you have a manual installed. It's just more like the absence of this causes all kinds of problems, because also without this, a lot of some functions from the ESP module won't work either, because the ESP module relies on information from the transmission regarding gearing torque loss, so that it knows how much torque is actually getting to the output shaft of the gearbox, because you have losses in the torque. Well, you actually have multiplication in your torque converter, and then you have loss inside the gearing itself in the gearbox. So the ESP module needs to know that, and so does the Distronics or cruise control module. I'm just having a look at what this was done here. Actually, bear with me for a couple of minutes. I'm going to go take my contacts out because I'm starting to feel my eyes starting to dry up. So I'm just going to leave it on this for now, and I'll come back in like 2 minutes. Okay, so I'm back. Just bear with me 1 second and I will open the screen back up again. Right, so there we go, we're back. Robert says, guys without TCU are having a lot more issues than just a pulley clutch not engaging. Yes, that is correct. So, I mean, you can quite literally just simulate this yourself. Just go ahead and unplug the transmission module from your car and just watch it how unhappy the car becomes. It's pretty simple. I mean, even what you could do as well, if you think that maybe they're running the stock HES module, is on the wiring harness. Oh no, actually, never mind. You can't do that because the connection with. I'll see if I can bring my mock valve board into view. but the connection to the CAN lines on the car here is the same connector which goes to the valve body. I was going to say if you could just unplug the valve body, then yeah, the gearbox will become very unhappy too, but it's still talking to the car. So I don't even know where to start with this now. Like, I've just realized like so much of this code has been, yeah, been written over the like a couple of years and stuff. So I don't want to particularly do too. No, I think the correct approach to this would be to create an I2C thread, which in the background just queries I2C, say, I don't know, every 20 milliseconds, because that's how most of the tasks on the TCU work. So within one cycle, which would be 20 milliseconds or so, everything gets updated and everything gets written. I think that's the appropriate way to do things, maybe. But I don't know. Right. So hash include ext abc.h. Driver I2C board config external ADC. External, that's what I'm going to call it. So then, yeah, actually, tell you what, let's just do some testing for now. I'm just going to go ahead and just initialize the external ADC blankly, and we don't do anything else more than that. So I think what I can do is here, just go ahead and comment all of this out. Actually, we'll do it in the event that it fails. So I can come here and say while1, that's input manager, wrong task. Yeah, so we can just say here external. No, I'll have to include the stupid thing. External ADC. So we can just say external ADC equals external ADC board config dot GPIO con. Is it GPIO config? What did I call it? It is a PCB GPIO matrix. PCB GPIO matrix dot new external ATC matrix, and I'm gonna just actually uncomment all this out so we don't beat. PCB matrix dot I2C STA PCB GPIO matrix dot I2 STA. What did I actually say the pin definition was? SCL. There we go. So now when I reset the board, it should just immediately go to this, I think. Just so we can play around for a little bit. Private ESP in its status. What on earth happened to... Oh, I forgot. A closing bracket. That's what happened. So technically this should compile now. Please do something. Oh boy. The answer is no, it didn't like it. Actually, we're gonna then just go ahead here. Oh, this is why, because these are all copied. So we just get that. And I'm gonna get rid of this too, because we don't need that. Then we can go here. Nothing matches. What on earth happened to the IntelliSense here? Because like everything's going white. I don't understand this. Expected a closing bracket. Oh. Maybe it's just too late in the day for me. I'm getting tired of this. But why doesn't this like it? I don't understand this, because I copy this, I go here. Oh my god, what's happening now? And I can paste it, but it still complains, saying it's expecting a closing bracket. Expected a closing bracket before the identifier SDA. Also, yes, Robert, yes, it still requires a lot of data for everything to work perfectly. Like, the guy with in chat with glyphs, I do not even understand. I believe it's Greek. I don't want to insult anyone. Supercharger clutch to engage, you need the gearbox not in pocket. Yeah, that could actually be true, because I know the behavior of it is that there are I know behavior is that in park and neutral your supercharger clutch does not engage. So that could be it. And by default the car, I believe, thinks it's in park or neutral if there's no TCU. So that way it can actually start. So I don't understand what this is. Why are you complaining like this? Maybe Michael. Maybe you're right. Include drive. Ah. See, also it's not letting me. What on earth is this? Why do I have all these AVR stuff? It's not letting me include anything from the ESP library anymore. Let's just reload the window. Maybe Papa is just having a bad day. Clearly not, it's still doing it. The only thing is that it's... Okay, where's GPIO loop? Driver / GPIO. Yeah, it is driver / GPIO. So copy this here. Are you gonna build now? Oh, maybe. I think it's building. Oh, yay, it linked. Okay. So, I'm just going to say while1 here. So you put in its state and just say here, printf, ADC OK. If it can initialize the ADC and then v task delay 1000. So if we get ADC OK message on there, then we know that we can start talking to it. ITC driver install error. Because it's already installed the driver elsewhere. Maybe. Okay, let's do this then. And we just go here, and then we just say immediately return speaker postcode, some random failure. Oh, see, now it's uploading by itself. Now to touch it. Okay. I'll take that as a win. Oh god. LDC set frequency panicked exception under what happened here? Failed to set upgrade. Why are you trying? Oh. Right. Because I think it's trying to initialize the IO expander and then it's crashing. So I also have to then go ahead here and uncomment something. There's a constructor somewhere here for this. PCB 13. Oh, here it is. So I have to comment out all of this stuff regarding the IO expander too, so it doesn't try initializing the 80s that twice. Just want the ADC to work today, and then I'll be happy that we're getting somewhere. Nope. ADC is not initialized. Fine. I'll do that. So luckily for me, I have a tool which can decompile that backtrace. CD code, ESP, RVB no exception encoder, vim dump, and then we paste that, and then we do run unified, and now voila, I have a backtrace. Vport into critical shared instruction ISR. Where is this from? Speaker set frequency apparently is where it died. Speaker set duty. Okay, fine. You know what? We're gonna just say no speaker for you. Oh, that does make sense because it didn't actually initialize the speaker. Okay, come on, now please work. Yay, look, ADC okay. I'm also going to go ahead here and I'm going to go and uncomment that. And that way it can't keep beeping at me. We have ADC okay, so now I have to figure out what to do to query it. Config registers. It's 4 registers accessible with an ITC interface using the address pointer register. The conversion register contains the result of the last conversion. The config register is used to change the operating mode and query status of the device. The other 2 registers, low fresh and high fresh, set the threshold values used the comparator function. Oh, now that's handy. I can set a minimum and maximum. I didn't know I could do that. what I don't understand here is there's one conversion register. Do I have to set the pointer to which one I want you to read? Because there's 4 channels. Guess you have to do some reading. Oh, there was a bit there about does not have an input. Oh, I see. So yes, I do have to switch between the rails. So I have to say, like, I want A in 0, read the conversion. A in 1, read the conversion. A in 2, read the conversion. A in 3, read the conversion, etc. Okay. Well, I mean, if this is correct, then I can. What was to say? Operating state when writing, no effect. When reading. This is nice. I can also set a gain and everything. That's quite handy. Device operating mode. This bit controls the operating mode. Continuous conversion. I want to see what this does. Okay, so I think I see how to do this. First of all, I have to update config register to say okay, let's try I2C master slave master write read device I2C I2C num 0. Device address should be OX48. And then I think we need just 1 byte, 2 bytes. 16-bit config register. Data format, here we go. It contains 16 bits of data in 2 components format. Oh no, wait, this is for output. So I think it's just 1. Okay, so I'm going to say 2. I should always get 2 bytes back, so let's just do this UN8 T rep equals how long has it taken you, so chat asks, how long has it taken you to learn hardware and software engineering? I've never seen anyone else go into depth. Have you gone to before? It's taken me a long time, and also on my day job I kind of do a lot of automotive stuff, so mainly reverse engineering stuff, so like, but mind you, I got my job because of my YouTube channel, not the other way around. So yeah, I mean, it's just kind of like I play and I like to tinker and like to add stuff to my car, and I guess once you realize what you're capable of, because you realize like, oh, I can now design my own boards, or like from something like a simple circuitry, like, hang on a second, let me go grab something. Like, this here. Also, I've just realised my camera's turned off apparently, so that's new. I didn't know it's turned off. Let me see if I can restore that. Or it's just completely not working at all. What's going on? For some reason, nothing's happy with me today. Okay, so for whatever reason, my camera seems to be off. I'm not too sure why. So I guess I can just like delete me from the scene, or maybe I'll re-add myself in. Yeah, that's true. I've just seen a message pop up in chat saying learning process never ends. Yeah, that's pretty much correct. So like this, actually, let's just go pro view. This is the first board I made on this, and I had made this after like 6-7 months of like kind of learning basic circuitry and stuff, and you can see the simplicity of this board, right? You know, nothing here is small, nothing here you can't hand solder, and then you step it up to this thing now that we've got our hands on, where everything's so much more complicated, so much more smaller. I think the smallest components here I'm using is 06, these guys here are 0603. Actually the ADC, that guy's actually got 8 pins on him, and he's like way smaller than my finger. I mean, it's never a learning process. It's a good learning process though, and then once you realize like, oh, I can design this, then that kind of opens the door to, well, what else can I design? And then you just kind of start going wild, because like I've got plans for displaying, like you see some of my videos about the car PC. I'm going to design maybe this summer a board for the display module, which is more integrated, because currently I have, see if I can find a picture of it, but basically it's a cannibalized Ultimate NAG52 PCB with like 20,000 wires coming from it, which go to the various parts of the display to control stuff like brightness or CAN and stuff like that. So it's not a great solution, and I do need to improve that. But yeah, it's just like you realize once you start doing it once or twice, like you design a small board and then you realize, okay, I've worked out how to do that, it works successfully, let's start designing more complex things. And then you end up in this world where you've suddenly now put like all automotive grade components on this board. Well, apart from the processor, this is the one thing which bugs me about the ESP chip, is I've tested it personally in a heat chamber at work. It works perfectly at -40 and +110 degrees Celsius, but it doesn't quite meet. I don't think they've got it qualified for the automotive spec, and therefore I can't say it's automotive grade. But everything else on here is, just not this. I mean, this guy here, this is the most expensive chip. This, to put it in perspective, this here costs about 5-6 times more than the actual processor. That just goes into the automotive specification, like how much expensive everything is which can withstand that type of stuff, or is at least certified to. Or maybe it's just an Infineon thing. But I'm now playing with big toys, which is like these expensive stuff here. But I think a year ago I said the reason why I designed this board like this, the 1.3 board, is because I wanted it to be easier to solder, and putting this I2C expander on here was a stretch. And now there's that, the ADC, and this guy on this. So I mean, I do end up expanding stuff. But yeah, I think I'm going to call it a night tonight, and I think I'm going to probably come at this later in the week with like much better setup, because I just literally decided to start doing this impromptu. I was just like, oh, I'm going to stream tonight. But I think I hope you guys, well, at least I hope you guys enjoyed this, and I do hope that at least there wasn't too many technical issues. I need to get a better setup and more robust setup to be ready for next time, and I think things will go a bit smoother. So I think I'm going to call it a night tonight, because it's late for me and I have an early start tomorrow morning, as always. Just one more thing actually, let me show you just how much more complex the board is. Let's go back to this scene where I've got my KiCad open. So as you can see, I've got my schematic here for the board, and I can actually show you now the mess which is actually on here. I have designed a little bit since I've made this current board. I'm just going to move this out so you can just see the raw wiring. And you can see here it's a quad layer PCB with like teardrops and everything. Like, it looks really good. And I kind of learned over time. Like, I have another project. Let's see if I can bring that up on here as well. Open project. It'll be under CAD. It'll be CAD 211 head unit rear PCB. I think it's this project. This card changes from accidentally done. Yeah, it's this. This is the board which sits in the back of my car, which does the amplifier and stuff. This was the biggest learning curve because it has audio, and audio is extremely sensitive to noise and various signal interpretations. So this is what this PCB looks like, and as you can see, it's a quad layer board again with really weird ground planes and layout. So you've got like a digital section, analog section for the amplifier. This was, I think, I went through 5, 6, or 7 revisions of this board, and even now I'm not 100% happy with it because I can't drive the Harman Kardon speakers with it because these amplifiers aren't powerful enough to drive those. It can drive the speakers in the base model 211 amplifier setup, but the Harman Kardon one it cannot drive. The speakers are too much resistance for these to drive without like seriously overheating, so I need to get better at that. And actually the Harman Kardon amplifier, or in the audio gateway, comes with 4 amplifiers. It's crazy. But I want to design something like that at some point, which is going to require modification. So essentially this was the hardest bit here, is that I've got USB data lines coming in from the PC, which go to this chip, which is a USB sound IC, which converts which splits out into 5.1 surround sound, because that's perfect because I've got 4 speakers like in the front 2 doors and the rear 2 doors, the subwoofer at the back and the center at the front. So this was perfect to split it into a 5.1 surround. But I kept finding like you would run a data line under here or something, and then just you get hissing noises from the PC in all of your speakers. It's awful. I then realized over time that I need to have more capacitors here, and I need to also put an inductor here to separate the battery supply from the power input to the board, such that you don't get any inductance on the, well, not inductance, but the noise from the alternator in the car inside the speakers. Like, it's just a massive ball ache because it's like really disheartening when you go through the effort of designing an entire board like this, and you're like, okay, this is going to be great. It's like the 5th time I've designed it, and then you go spend, well, it took me what, maybe 3 weeks to design an iteration of this board. Then you go wait for the parts to arrive. You're so happy when your board comes, and then you sit down there for 3 hours assembling the damn thing by hand, and then you suddenly realize you plug it into your car and there's noise on the speakers. And just honestly, every single time it happens, it just angers me so much, and you just go, well, back to the drawing board, and you go ahead and just basically just get upset. And then you go back to the drawing board and you do some more research and you realize, why hasn't this worked? And then you edit again, do it again, 5, 6, 7 iterations later. And I actually think the worst thing was when I was in Germany for work, and I decided I was going to order this, for the previous iteration to this one, to my workplace, because I wanted to assemble it there because I had a presentation in Berlin where I was going to see some people, and I was like, for a personal thing, I was like, I want to go show this off as well. So I designed the boards, and then they got held up at customs, and then DHL did not let me actually have the boards, so they were in customs for 3.5 weeks before they sent them back to JLC PCB. And then by this point I'm now back in the UK, and I'm just now getting really disheartened because I couldn't do this. Well, what does that mean? Ads inserted. Anyway, yeah, it was kind of disheartening because I've waited 3-4 weeks for the boards because they got stuck at customs, and then I go and assemble everything and test it, and it doesn't work, and there's just noise from the speakers. I'm like, this is worse than the previous iteration. And I found out literally it's because I just had like a trace running under one of the analog lines, and it's causing like from, I think it was one of the digital lines for the USB going under this, and that caused all my problems. And then also, so yeah, I'm getting sidetracked now. Robert also asks, why did you create, so I get why you created the other boards, but why didn't you opt for an existing amp for your own brand? Simply because I wanted something integrated, I guess, because I wanted 5.1 speaker surround sound, because I have plans for the PC whereby, when I eventually get around to adding navigation, I want the driving directions to only come out the driver's side speaker, so I need precision control over the sound. I can't just be like left and right channels. I need like each individual channel to be driven by the PC. So that then meant I needed a 5.1 audio processor IC, but then I also wanted the stock wiring harness for the speakers to connect up to this. I didn't want to have like to solder the wires or to de-pin them and pin them to a different header or something. So I just kind of said, you know, I'm designing this bit myself, and I'm also designing this bit myself, so I will just go ahead and put my own amplifier on. And to be fair, I did use something which the original amplifier used in the car. These, let me show you which amplifier IC I'm using. Speakers, so these. Yes, I do need 7.1 for the W211 Harman Kardon system, because that also has 2 extra speakers. So yes, I need 7.1 for that, and technically then you can emulate like side back, side rear, but then I also need to get a wiring harness and everything. Anyway, back to what I was going to show you. So this guy is used in the original, well, it's basically a successor part to what is already in the original 211 audio gateway module. So I just kind of went off that. It's a 4x48 watt MOSFET quad bridge power amplifier. You could also use a DSP for the 7.1 system. DSP, let me just quickly get my terms right. DSP audio, what do you mean by that? Digital signal processing. Taufik, can you explain what you meant by DSP for that? I'm just getting a bit confused. But yeah, like, to be fair, I didn't pay too much attention when picking the TDAs for the actual characteristic curves, because I don't understand what a lot of this meant. But I guess you just kind of find out over time. Like, you design it, you realize it doesn't work, and then you look maybe and you realize eventually, like, someone points out to you why it's not working. Also, what's really interesting here is this TDA chip. 14.4 volts is the exact voltage that my alternator charges up and cars from the similar generation from Merck. So I feel like either the alternator is designed based on the audio and everything else in the car, or everything else in the car is designed for a common voltage of 14.4 for whatever really weird reason. Maybe it's something to do with charging the battery. But yeah, a lot of these circuits here are designed based on the datasheets, because some of the datasheets do come with like example schematics on how to lay things out. So there was that, but none of the datasheets I had information. Digital sound processor, like the Audison. Oh, digital sound processor. Yeah, that's a good shout actually. I know that the Harman Kardon system has a DSP in it, and then it also has a microphone in the car which it uses to for corrections. So if you actually have the Harman Kardon system in your 211 and you remove the microphone or unplug it, I think I'll send a picture maybe in Telegram later where it is. But if you unplug it, the sound system sounds really different, because it can't. I believe it's using that microphone to correct in real time the audio of the car coming out the speakers. Like, it's so over-engineered for 2003. And I want to put the Harman Kardon system in my car at some point, because believe it or not, it doesn't actually have it. It had Harman Kardon badges on the side of the door panels, and then I just realized they were just stickers. Like, there's some guy who owned the car previously had just stuck them on for whatever reason. Whilst we're on the topic of previous things that my car has done, or previous things that my guys who own my car did, I changed my exhaust manifold this weekend. and it looked like they had, at some point, the flange on the manifold had snapped off, and they'd welded it from the inside, and that weld had deteriorated because of the heat, and then it's leaking. So I'm happy I've got a much quieter E55 now. It doesn't wake up the neighbours every morning. So yeah, I think that's it for this stream. I think we will come back to this later, either this week or early next week, and do more support, maybe during the daytime as well, because that way I'm not so tired. Also, I thought I'd mention this here, regarding board orders. I'm going to put an announcement on the website. From the 22nd to about the 3rd of June, I'm not free because I'll be in the States, so I won't be able to ship anything. So I'll put a notice up on the store to let people know that there will be no orders being processed during that time. So yeah, I think that's about it for this one. I hope you guys enjoyed, and I will be back with a better streaming setup soon. So goodbye everyone.